In this section, we're going to be looking at quadratic equations. So let's first, at the top of your notes, define a quadratic equation. It's an equation equivalent to one of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a does not equal 0, meaning you have to have a squared variable for it to be quadratic. A quadratic equation is a second degree equation, whereas we talked about linear equations as being first degree equations. So there are several factors for solving a quadratic. The first one is factoring, which you have seen before. In fact, all of these methods you have seen before. So in the steps for factoring, the first thing we want to do is write our equation in standard form of ax squared plus bx plus c equals 0. So we want to get it equal to 0. And then you use the zero factor property, which says if a times b equals 0, then either a equals 0 or b equals 0. So let's try a couple of those just quickly. So when we look at this one, I immediately notice one thing first. There is no domain restriction because there is no variable in the denominator. This is a factor out the GCF type of factoring. I know because there's two terms and it's not difference of two squares. So I factor out a 3x as my GCF and I'm left with x plus 2 equals 0. Now I use the zero factored property to say either 3x equals 0 or x plus 2 equals 0. Here I divide by 3 to get x is 0, and here I subtract a 2 to get or x equals negative 2. And I get two answers, a 0 and a negative 2 for x, and that's what you should get in a quadratic. You should get two answers. It can also be shown like this. This one is not in standard form. I need to get it in standard form by subtracting an x and subtracting a 3 from both sides. I'm doing that in one step. Don't let that freak you out. So I have 2x squared minus x minus 3 equals 0. This is a trinomial. It is a long process trinomial. I know that because there is a 2 in front of the squared term, not a 1, but something other than 1. So we say 2 times negative 3 is negative 6. I want factors that combine to make negative 1. Right there, my middle term's coefficient. That is a negative 3 and a positive 2. So I now bring down the first term. I break down the second term into these two pieces. So plus 2x minus 3x, bring down the last term. Now because I have 4, I'm going to group. And because I have a negative in between my two groups, I make the correction on that last term by turning it into a positive. Factor out the GCF of the first binomial and write what's left. Bring down your minus sign. Factor out the GCF of the second binomial and write what's left. Since those match, that is my first factor, and my second factor is 2x minus 3. Now we're ready to use the zero factor property. So either x plus 1 equals 0 or 2x minus 3 equals 0. We're going to solve those two little equations. Here by subtracting a 1, and I get x equals negative 1. Here I'm going to add a 3 and divide by 2. So I have x equals negative 1 or x equals 3 halves. And I have my two solutions to my quadratic equation. In C, we also have a long process trinomial, so I want factors of positive 9 that combine to make negative 6. That's going to be negative 3 and negative 3. So I'm going to break down my middle term into negative 3x, bring down the last term. Now we're going to group. Because of that negative, I make a correction on that last term. Factor out the GCF of 3x you're left with 3x minus 1. Bring down the minus, factor out the GCF of 1, and you're left with 3x minus 1. So my first factor is 3x minus 1. And in this case, my second factor is also 3x minus 1. So there's no reason to set both of them equal to 0. It's going to come out the same. So we just say 3x minus 1 equals 0, and we solve that equation, and we get x equals 1/3. Now there really are two answers, but it's just 1/3 and 1/3. So there's no reason to write it twice. It's a repeated answer because our original equation was a perfect square. All right, let's look at the second method for solving a quadratic equation, and that is using the square root property. So it's used to solve quadratic equations that look like this, where there's something squared, whether it be just a number or whether it be a binomial or whatever is squared. So let's look at one. We're going to isolate the term that is squared and get everything else on the other side. So with factoring, we got it equal to 0. With square root property, we isolate that thing that has been squared. So here, I see that 2x minus 1 has been squared. To isolate that, I have to divide by 3, and I get 2x minus 1 squared equals 4. And now since the term that is squared has been isolated, I just take the square root of both sides. But what you have to remember is the square root of anything squared is just that thing, but the square root of positive 4 is plus or minus 2. So this is when you have to split. You say 2x minus 1 equals positive 2, or 2x minus 1 equals negative 2. And you have to do two different equations. So here I add a 1, 2x equals 3, divide by 2, and I get x equals 3/2. Here I add a 1, 2x equals negative 1. I'm running out of space. Divide by positive 2, and I get x equals negative 1/2. So for this one, I'm going to write my solutions. Well, I guess I've got space right here. My solutions are negative 1/2 and positive 3/2. Not much space down here. All right, for this one, in order to isolate the term that has been squared, I first have to subtract a 10, giving me negative 2 times the term that was squared equals negative 10. And now I divide both sides by negative 2. And I have x plus 3 squared equals a negative divided by a negative is a positive 5. Take the square root of both sides, and I get x plus 3 equals plus or minus radical 5. Let's continue this up here where I have some space. So x plus 3 equals plus or minus radical 5. And now I just subtract a 3. And be careful how you write this. X equals negative 3 plus or minus radical 5. And I still have two answers. It's negative 3 plus radical 5, negative 3 minus radical 5. Okay, let's look at the third way that we can solve a quadratic equation, and that is called completing the square. So there are directions up here for completing the square, and what you want to do this time, what gets isolated, because this one is not equal to 0. So what gets isolated are the variables on one side and the numbers on the other. And then we have to make sure that the squared term has a coefficient of 1. I'm not going to give you any that don't. I'm just going to tell you that right now. And then we'll go through the process. So in example 3, it says determine the number that should be added to each expression to complete the square. Now, we are not going to do the whole process. We're just going to determine what is that magic number that you add. And the way that you do that is you take the middle term, so positive 8, including its sign, you divide it by 2, circle that, and then square it. So here I would add a 16. Now factor that as a perfect square. It's going to be x and then what you did in the circle plus 4 that got squared. That's why you circle it, to help you see that. Here I'm going to take positive 12, divide it by 2, I get positive 6, circle it. Square that and I get 36. So what is it going to look like factored? Remember the circle, it's going to be x and then what's in the circle squared. On this one, negative 20 is my middle term. Remember, you must include the sign with it. Square or circle that and now square it. That gives me 100. That's always going to be positive because I'm squaring. But factored, it's going to be the a and then what you circled, minus 10 squared. This one, a little bit harder. Take your negative 5, divide it by 2. You don't want to write 2.5. You're just going to leave that. Now we square negative 5 halves and we get 25 fourths. So that's what I add. But when I factor it, it's p and then what you have in the circle, minus 5 halves that got squared. So let's kind of put it all together and let's do one that's already been set up for you correctly. So the x's are on one side, number on the other. So we're going to write x squared plus 4x plus some magic number equals 21. So take that 4 with its sign, divide it by 2, write it with a sign and circle it. Now square that. That's what I add to both sides. We didn't have another side up here, so we didn't add to both sides. Now I factor this just like I did above, so that's going to be x plus 2 that got squared equals 25. Take the square root of both sides. I'm now down to the square root property. So x plus 2 equals plus or minus 5. Now split it. X plus 2 equals positive 5. X plus 2 equals negative 5. Solve those two equations and we get x equals 3. Subtracted 2 here and we get x equals negative 7. So those are your two solutions, negative 7 and 3. All right, let's do another one that is not set up correctly. So we're going to subtract a 4 from both sides first to isolate x squared plus 5x plus some magic number equals negative 4 plus the same magic number. Take your positive 5, divide it by 2. Since that's all you can do, just circle it, square that, and you get 25 fourths. 25 fourths to both sides. This one's more work because my middle number wasn't even. Factored, it is x and then what's in the circle, plus 5 halves that got squared. Now over here, let's do this on the side. We have a negative 4 over 1 plus 25 fourths. So I have to have an LCD, which is 4. So I multiply by 4, and I get that that is equal to negative 16 fourths plus 25 fourths, which is 9 fourths. So on this side, I have 9 fourths. Now I'm ready to take the square root of both sides. So x plus 5 halves equals plus or minus 3 halves. That's the square root of 9 fourths. Split it into its two pieces. X plus 5 halves equals positive 3 halves. X plus 5 halves equals negative 3 halves. Subtract 5 halves from both sides, and here I get x equals negative 2 halves, or negative 1. There's one solution. Here I subtract 5 halves and I get x equals negative 8 halves, or negative 4. So I have my two solutions. It's not as easy when the middle term, like I said, is not even. So quadratic formula. The quadratic formula is the other one along with factoring that you get equal to 0. So there's not a lot of space here, so let's write this quadratic formula at the bottom. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's try a couple of those. I think I've got 3 on here. And remember, to get it set up, you have to get your equation equal to 0. So here I'm going to subtract a 1. 4x squared plus 2x minus 1 equals 0. Now my equation is ready. So I'm going to come into the side. I'm going to label my a, my b, and my c. A is the number in front of the squared term, the coefficient. B is the coefficient of the unsquared term, and c is the final number. And now we just plug in. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Or x equals negative 2 plus or minus 2 squared is 4, and negative 4 times a negative 1 is a positive 4 times 4 is 16 all over 8. X equals negative 2 plus or minus square root of 20 over 8. You cannot simplify at this point because of this 20. So I'm going to break that 20 down. So negative 2 plus or minus 4 times 5 all over 8. Pull that out. Let's write this up here. So I have x equals negative 2 plus or minus 2 radical 5 all over 8. Now I can cross cancel. 2 goes into 2 once, into 2 once, into 8 4 times, and we get x equals negative 1 plus or minus 1 radical 5 all over 4. And that is your answer. You've got to be careful with the details on these. On this one, I'm going to show you a little trick. Will be nice if you could see it. If your x squared term has a negative in front, multiply everything by negative 1. And what that is effectively going to do is change all the signs. So it's going to be positive 3x squared minus 6x plus 1. 0 times a negative 1 is still 0. That makes it much easier to deal with when we name our a, b, and c. So my a here is 3, my b is negative 6, my c is 1. And I get x equals the opposite of b. Now b is negative 6, so that's going to be positive 6, plus or minus the square root of b squared minus 4ac all over 2a. Or x equals 6 plus or minus square root of 36 minus 12 all over 6. X equals 6 plus or minus square root of 24 over 6. You cannot cross cancel yet. We're going to break that down into 4 times 6, and we're going to pull out the square root of 4. So x equals 6 plus or minus 2 radical 6 over 6, and now we can cross cancel. 2 goes into 2 once, it goes into 6 3 times, and we end up with x equals 3 plus or minus 1 radical 6 over 3. Again, it's the details here that will get you. And let's do this last problem, which is an application problem. It says find the dimensions of a rectangle. First thing I'm going to do is draw a picture. A rectangle, length, width, whose perimeter is 26 meters, and whose area is 40 square meters. So that we know that perimeter is 2 L's plus 2 W's, and I also know that that's equal to 26. So here's an equation that is probably going to be usable. Area equals length times width, or I'm given the area, so I can say 40 equals length times width. Now, I need to solve this equation for either the L or the W. I'm just arbitrarily going to say I'm going to solve it for L. It doesn't make any difference. So I'm going to divide both sides by W, and I have L equals 40 over W. And what am I going to do with that? I'm going to replace this amount, 40 over W, for the L in that equation. So my perimeter of 26 is equal to 2 times 40 over W plus 2W. Now we need to clean this up. So 26 equals 80 over W plus 2W. Now I need to clear my fraction of its denominator. So I'm going to put each term in parentheses, and I'm going to multiply by the LCD of W. That's what the LCD is. What's going to happen is I'm going to get 26W, those cross cancel, equals 80 plus 2W squared. Continuing that, I have 2W squared. Now let's bring this over to the other side, minus 26W. I'm just writing it in the correct order, plus 80 equals 0. Well, the first thing I notice is that these are all even numbers. So I'm going to divide this whole thing by 2 to begin with, both sides by 2. That's going to give me W squared minus 13W plus 40 equals 0 divided by 2 is still 0. Now I have a short process factoring instead of a long, because I could factor out that 2. So I'm looking for factors of positive 40 that combine to make negative 13. That's negative 8 and negative 5. So I'm going to say W minus 8, W minus 5 equals 0. Now we use the 0 factor property. So W minus 8 equals 0, or W minus 5 equals 0. Solve those, and I get the width could be 8, or the width could be 5. It doesn't matter which is which. If I call it 8, then the length, I had this great formula right here for length. The length would be 40 divided by 8, which would be 5. Or if I call the width 5, the length would be 40 divided by 5, which is 8. So we're used to thinking of the length being the longer one, so it'd be length 8, width 5, but that doesn't necessarily mean that. The length could be the shorter one and the width could be the wider one. So it's either length equals 5, width equals 8, or length equals 8 and width equals 5. And I forgot they were meters. I'm going to write meters here. Either way, both of those answers, those combinations work.